In Chapter 4, we will be introduced to mathematical functions, characters, and string objects. We will add these tools to our toolbox and use them to develop programs. Java uses a special notation called an escape sequence to represent special characters as shown in this table. An escape sequence is the escape character, the backslash, followed by a character or a combination of digits. So \t, for example, represents the tab character. Java considers an escape sequence as a single character. For our purposes, we'll focus on the escape sequences for tab, the \t, for line feed, the \n, the backslash, which is a double backslash, and then for the double quotation mark, which is backslash and then a double quotation mark. And we'll use these escape sequences in our print statements to allow us to do things like print out double quotes, to print out the backslash character itself, or to aid us in formatting our output. We can use casting between the char data type and any numeric data type. So this means that we can cast a character into an integer or a double or any other numeric data types. And likewise, we can cast an integer or a double or any of the other numeric data types into a character. Implicit casting is done automatically, and this is because the result fits into the target variable. If the result does not fit into the target variable, then we have to use explicit casting. Explicit casting is what we used when we were trying to generate random integers using the math.random function. And so we had to enclose int, representing the integer data type, in the parentheses to do some explicit casting. The relational operators greater than equal to, less than equal to, etc. can be used to compare two characters, and this is done by comparing the equivalent Unicode for each character. By using the relational operators, we can determine alphabetic order, among other things. The code that we see in this slide determines if the character CH is an uppercase letter, a lowercase letter, or a numeric character. You'll notice that the single quotes are used when comparing the character CH to the uppercase A or the uppercase Z, etc. This is because they're characters, not strings. Remember, we use the single quotes for characters, the double quotes for strings. You'll also notice that the double quotes are used in the print line statements around the various strings. And when we use the plus sign with the variable ch, we effectively concatenate the character ch with the string that's in double quotes. The character class contains several useful methods. Like the math class, we do not need an import statement to use the methods in the character class. We must, however, use the dot notation to use these methods. Each of these methods has one parameter of type character. The methods to lowercase and to uppercase return a character. All of the other methods return a Boolean. you'll note that camel case is used in the name of these methods. And remember, Java is case sensitive, so when you want to use these methods, it's important that they be capitalized as specified. The character data type, char, represents a single character. If we want to represent 2 or more characters, we must use string. You will notice that the char data type begins with a lowercase letter, but string begins with an uppercase letter. This is a clue to an important distinction. The char data type is a primitive data type, while string is actually a class in the Java library. We've used other classes such as math, character, system, and scanner. Additionally, you will recall that we created something called objects of the scanner class, and when we did so, it felt a little like we were using the scanner as a data type. Well, we use scanner as a reference type. String is also a reference type. In fact, any Java class can be used as a reference type for a variable. Everything that isn't a primitive data type is a reference type. This will have significant implications, and we'll see those shortly. In Java, strings are objects. We are not going to go into great detail about what that means, but for now, suffice it to say that when we declare a variable to be of type string, we are creating a reference variable that references an object. Additionally, the methods in the string class are instance methods. This means that we need to have an instance of type string to use these methods. By instance, we mean an object or a reference variable. So we must have declared a variable of type string to invoke instance methods in the string class using that variable. It's also worth stating that when we invoke or call an instance method using a variable, we use dot notation. Methods that are not instance methods are called static methods. Static methods can be invoked or called without using a reference variable. All of the methods in the math class are static methods, as well as system.out.print or printline and system.exit. Next int and next double and close are instance methods because when we call them, we must use the name of our scanner. The syntax to invoke an instance method is the name of the reference variable, a dot, and then the method name with an open parentheses, the arguments or parameters required for that method, and close parentheses. The syntax to invoke a static method is class name, dot, method name, open parentheses, whatever parameters are necessary for that method, and close parentheses. Even if a method requires no parameters, we still must code the parentheses when calling that method. Please refer to the previous coding examples to further realize this difference. The table shown in this slide lists some of the most useful methods found in the string class. All of these methods are instance methods, therefore we must invoke them using a previously declared reference variable of type string. Take a few minutes to read over the table and familiarize yourself with the various methods. Note how many parameters each method requires. Remember, even if a method requires no parameters, we must still code the parentheses when calling the method. We can determine the length of a string using the method length. This will return an integer indicating how many characters are in the string. In this example, we declare the reference variable message to be of type string and initialize it to Welcome to Java. When we want to determine the number of characters in message, we call the length method. The syntax is as shown. Message.length, open paren, close paren. You can also call the instance methods in the string class using string literals, which are enclosed in double quotes. Sometimes we may want to retrieve a specific single character from a string. Each character in a string has an index that indicates its position in that string. The first character in any string has index 0. The second character has index 1, etc. The index of the last character in the string named message is message.length minus 1. This is because we started counting the characters at 0 instead of 1. If necessary, you may want to work through a few examples to convince yourself of this. If you code message.char@, message.length, you will get an out of bounds error. This is because the 15th or last character in message has an index of 14. The last character in message is coded as message.char@, message.length minus 1. Up to this point, we've used the plus sign to concatenate strings. This has allowed us to concatenate 2 or more strings. The string class also includes the instance method concat that allows us to concatenate 2 strings. You will see in the example that we can concatenate S1 and S2 and store the resulting new string in S3 using either the concat method or the plus sign. If we use the concat method, we code it as s1.concat, open parentheses, s2, close parentheses. You will want to note that this is not equivalent to s2.concat, open paren, s1, close paren. Take some time to code this both ways and understand the difference. You should also recall that when we use the plus sign, if one of the operands is a string and the other is a non-string, the non-string is converted to a string and the 2 are concatenated. This is shown in the example of concatenating the string literal chapter with the number 2 and storing the resulting string, chapter 2, in the string s. Likewise, we can concatenate a string with a character using the plus sign, as in the example of the string literal supplement plus the character literal b. Results in the string supplement b, which is stored in the string s1. Notice that because b is a character literal, it is enclosed in single quotes. However, supplement, a string literal, is enclosed in double quotes. The string class provides several instance methods for converting a given string into a new string. The instance method toLowercase returns a new string with all lowercase letters. Likewise, toUppercase returns a new string with all uppercase letters. The instance method trim returns a new string with all of the white space characters trimmed off both ends of the original string. Previously, we have allowed users to input numeric data types, specifically integers and doubles. Now we will consider how to allow a user to input a string. The scanner class gives us 2 instance methods to read in a string from the console, next and next line. It is important to know that these methods are instance methods in the scanner class, so we use the name of our scanner when invoking them, the same as we did for nextInt and nextDouble. The method next reads in a string that ends with a white space character. To read in an entire line of text, we must use nextLine. NextLine reads in a string that ends with a line feed when the user presses the Enter key. We may also want to read in a single character from the user. To do this, we can use the next line method from the scanner class and then invoke char at 0 on the string that was read in to pull off the first character. The string class offers us several methods for comparing strings. To reiterate, all of these methods are instance methods. This means that they must be called from a specific instance or object, a reference variable, and use the dot notation for the call. It is a common error to use double equal signs to determine if two strings have the same value. Don't fall into this trap. This is a logical error. If you use the double equal signs, you are actually asking if the two reference variables refer to the same object. You're not comparing the contents of the two strings to see if they match. To see if the contents of string 1 and string 2 match, use the equal method. The equals method will return a Boolean value. As you might expect, equals will return true if the content of string 1 and string 2 match or they're equal. Otherwise, it will return false. Likewise, we cannot compare two strings using relational operators. We need to use compare to in order to achieve this. It is worth stating that when we compare two strings, we are considering alphabetical order. Therefore, S1 is greater than S2 if it comes after S2 in alphabetical order. Also, S1 is less than S2 if it comes before S2 in alphabetical order. So S1 dot compare to open paren S2 close paren returns a positive integer if S1 is greater than S2. It returns a negative integer if S1 is less than S2, and returns 0 if S1 equals S2. The equals method that we just saw is case sensitive. If we want to determine if the two strings are equal without case sensitivity, we should use the equals ignore case method. Similarly, we're provided with the compare to ignore case method for case insensitive comparisons of strings. The starts with method allows us to determine if a string starts with a given prefix. Ends with method allows us to determine if the given string ends with a given prefix. In both cases, starts with or ends with returns a Boolean value. The method contains tests to see if S2 is a substring of S1 and returns true if it is and false otherwise. We have covered how to obtain a single character from a string using the char at method. But what if we want to obtain a substring, a series of consecutive characters from the string? To do this, we need to use the substring method. The substring method is an overloaded method. It can take one or two parameters. If we want to obtain the substring starting at a specific index and ending at the last character in the substring, we can use the substring method with a single parameter, that is the index of the beginning index of the substring we wish to obtain. If we want to obtain a substring starting at a beginning index and ending at end index -1, we can specify the two parameters, begin index and end index. It's very important to note that we code this as a substring begin index, common end index, but end index is not included in the substring. The string class also includes the method index of, which is also an overloaded method. Index of returns an integer that corresponds to the index of the specified character of a string. This chart details how we can use index of to find the first occurrence of a character in a string, the first occurrence of a character in a string starting at a given index, the first occurrence of a string in a given string, and the first occurrence of a string in a given string starting from a given index. Please take some time to review this slide and experiment with coding using the index of method. Similar to index of, the string class also includes an overloaded method, last index of, which returns the index of the last occurrence of a character or string in the specified string. Please take some time to familiarize yourself with the last index of method. Now let's look at an example. Let's consider that we have a string S that contains a first name and a last name separated by a space. We want to extract the first name and last name into two separate strings we will call first name and last name. How do we do this? Well, if we use the method index of to obtain the index of the space character, we can determine how the first and the last name are separated. So let's store the value of that index in an integer variable called k. Now we can find the first name by using the substring method on the string S with parameters 0 and k. Remember, we use k, the index for the space character, because substring will return the substring from 0 to k minus 1, including k minus 1. For the last name, we use the substring method with a single parameter, k plus 1, because this is the first character in the last name. Since we are only using one parameter, substring will return the substring starting at index k plus 1 to the end of the string. So now it's time for you to try the challenge of reading in three strings: user's name, mother's name, and father's name, and then separating them into strings for each first name and each last name. Let's consider when we have a string representing an integer or a double value, and we want to convert it to an integer or a double data type. How best to accomplish this? Well, Java has two classes to assist: the integer class and the double class. We will not go into great detail, but for now, suffice it to say that we can convert a string containing an integer into an integer value using the parseInt method in the integer class. You will notice from the slide that this is a static method in that it is called using the class name integer.parseInt open paren numeric string close paren. Likewise, the double class has a method named parseDouble that we can use to convert a string containing a double value into a double data type. This is also a static method and is coded as double.parseDouble open paren numeric string close paren. Recall that if we want to convert a numeric data type to a string, we only need to concatenate it with a string. This is easily achieved by concatenating a numeric value with the null string. Please review case study 4.5.1 in section 4.5. Pay special attention to the logic. Also, pay attention to the escape sequence \n and understand that this is the escape sequence for a line feed. Which method calls are static methods and which are calls to instance methods? Consider the case study in listing 4.4. Read through the textbook to understand the logic. Review the case study in 4.5.3 and consider how this problem can be solved using different approaches. Notice that lottery digit 1 and guess digit 1 both use the char at 0 method. Remember that the first character in a string has an index of 0. Consider the compound Boolean expressions in the nested if-else statement in lines 25. When we want to display information on the console, we've used system.out.print or system.out.println. They get the job done, but don't offer much power in the way of formatting that output. We learned about escape sequences such as the \t and \n, and we've incorporated them into our print statements, and that helped in formatting output. But now we'll learn a better and much more elegant way, the printf statement. The syntax is system.out.printf, open parentheses, format, comma, items, close parentheses. The format is a string that consists of substrings and format specifiers. The format is enclosed in double quotes. Format specifiers begin with a %sign and tell the computer how an item should be displayed. Items can be Boolean value, so true or false, a single character, a decimal integer, which is just an integer, a floating point number, so a double or a float, a number in scientific notation, or a string. Each of these has a corresponding specifier. The format is enclosed in double quotes and followed by a comma. The items list corresponds to the format specifiers in the same order as listed. The item list must match the format specifiers in number and type. So if a printf statement has 3 format specifiers, there must also be 3 items in the item list. Additionally, if those 3 format specifiers are integer, string, and Boolean in that order, then the items listed must be of type integer, string, and Boolean in the same order as well. This table lists frequently used specifiers. Again, each format specifier begins with a %sign. You will recall that escape sequences begin with the \. We can use both format specifiers and escape sequences in the printf statement to precisely format output. You will see in the example that the printf statement has 2 format specifiers, %d for an integer and %f for a floating point, a real number. The items listed are count, which is an integer, and amount, which is a double. It is necessary to point out that %d specifies an integer, not a double. If we want to specify a double, we must use %f. Please review listing 4.6 and pay special attention to the printf statements to understand the formatting specifications. Consider lines 4 to 5. If we count the %signs, we can see that this printf statement has 5 format specifiers, and by counting the backslashes, we can see that it has 1 escape sequence. The format specifiers are all of the same type, string, and the escape sequence, \n, indicates a new line. It's important to note that the printf statement is not a println statement, and if you want a line feed at the end, you must include the escape sequence, \n. In the format specifiers, the 10 in front of the S indicates a field width of at least 10. This means that 10 spaces are allotted to display the corresponding string item. The negative sign denotes that the string item is left justified in the 10 spaces. It is worth saying that if an item requires more than the allotted 10 spaces, it would be given. If you look at the printf statements in line 10 and 17, you will notice that the format specifier for floating point numbers contains -10.4 before the F. As we discussed previously, the 10 allocates a field width of at least 10. The negative sign left justifies in that field. The decimal 4 is new, however, and it's unique to floating point number specifiers. The decimal specifies that the precision, or how many places after the decimal, will be displayed. In this case, exactly 4 decimal places will be displayed within a field of at least 10 and left justified. I suggest that you spend some time on this listing first to understand it as it is coded, and then modifying the printf statements to more fully understand its power.